All right, everybody, how we doing? Um, Here we go with our very next lecture video. This is going to be on uncertainty in measurements and why it's important to recognize that a lot of the measurements that we're going to be utilizing throughout the school year that we're going to be taking, right? Because again, measurements consist of two things: a number plus an actual unit, right? So there's going to be a lot of measurements that we take, particularly in the lab environment throughout the entire school year, right? And recognizing that there is going to always be some degree of uncertainty in these measurements is going to be really important. It's an unavoidable thing, but knowing what to do with this uncertainty is going to be something that we concentrate on throughout this entire school year. So let's take a look here. Again, all measurements are going to have some kind of amount of uncertainty. If, for some example, you get some number in your calculator, right, that's got this whole massive string of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 12 or 13 digits after the decimal point, right? That's, coming from your calculator. No one's ever going to ask you to report every single one of those digits, right? That's just too many and looks awful. It just doesn't really look very good, not super clean. And again, it adds to this degree of uncertainty. Now, what we can do to kind of help clean up that look of that number there is apply what's known as significant figures. And this idea and this concept of significant figures really does only apply to measurements, right? So if you're just looking at basic numbers like 11 people or a dozen apples, for example, right? Those aren't units of measurement. People and apples, right? Maybe they are in certain contexts, but not for the context of what I'm talking about here, right? So whenever we talk about something like meters or volume, right? So different types of volume measurements would be milliliters, for example, right? We use milliliters a lot, or grams for mass, right? Kilograms. These are going to be actual, legitimate, units that we're going to apply towards this idea of significant figures, right? And we can only apply, like I said, these significant figures to measurements. They do not apply to these things called exact numbers, right? So the number 1 is almost always going to be an exact number. The number of items or counting numbers, for example, right? 4 people are going to be, 4 people are going to be examples of exact numbers, right? So there's this idea of the difference between what things that are considered to be measurements and things that are considered to be exact numbers, right? And we're making sure that we're always recognizing that this idea of significant figures can only be applied to measurements, a number plus an actual unit, right? Whether that unit's grams, milliliters, liters, meters, you name it, right? As long as it's a measurement, number plus unit, you're good to go. Okay. Skipping over a couple of things here because we'll circle back to some of the problems, examples and whatnot in class. What is a digit, right? We look at these numbers here and we always try to think to ourselves, well, what exactly are digits? And trying to recognize what a digit is important for what we're going to be doing here because we have to be able to count the number of digits we've got here, right? So no matter what we talk about, guys, digits are going to be every single number 0 through 9, right? So that does include the 0 here, right? The 0 is technically a number, right? So when we look at this number here, 230, we've got 1, 2, 3 total digits here, okay? Now, this is going to play into it because of this set of rules here called the rule for significant figures, which we call the PLAR rule. PLAR is kind of an acronym. PL being present and left, and then the letters A and R are going to be absent, right. And we kind of get this. It's almost like a split down the middle here. This PL here is going to be, based off of this first bullet point here, which says if the decimal point is present, we're going to start counting from the left-hand side of that number until the very first non-zero digit and keep counting until the end. That's where, again, where the PL comes from, right? So if the decimal point is present, right, so this idea of present comes from, this decimal point is present, then we're going to start counting from the left, right? So that's where the P comes from and the L comes from, right? So P and L. And if we look down here at the second bullet point here, it says if the decimal point is absent, start counting from the right-hand side. So that's where the A and the R comes from in AR. So P, L, A, R all adds to this present, left, absent, right notion of how to count the number of significant figures in any digit, okay? And we're going to be able to very, very, very easily apply this concept here of the PLAR rule to several different digits. Let's just do one really quickly And like I said, we'll do a lot more of examples in class here. So when we look at this number here, right, this is a measurement, right? We look at this number here, and it is absolutely a measurement, right? We've got some number here, 2.12, followed by this guy right here, okay? This is a number plus a unit. Okay, as soon as you have a number plus a unit, that's exactly what a measurement is. Okay, so you have to have both. You have to have the number and the unit in order for this to be considered a measurement. And again, you can only apply this rule of significant figures to measurements. If we did not have this L here, if this was just 2.12, we would not be able to use significant figures here. Okay, important distinction. Now, when we look at this measurement here, we have to be thinking, hey, do we see a decimal point present? And of course, the answer is yes, right? We see the decimal point right here. It's between the very first two on the left and this one digit right here, right? So there is a decimal point present. So we should start counting from the left-hand side of this number here, right? The left-hand side being this very, very first two over here. So count every single digit and making sure that the first digit you start counting is a non-zero number. Well, what are non-zero numbers? They're going to be anything from 1 all the way up to 9, right? Of course, I mentioned before that our digits consist of 0 through 9, but of course 0 is not going to be a non-zero number because it needs to not be 0, okay? So we start counting with the very first non-zero number from the left-hand side here, right? That's what we call this, the PL side, right? So present left. So we start counting with 1, 2, 3. That means we've got 3 total digits we just counted from the left-hand side here. So the number of significant figures in this number from this measurement is going to be a total of 3 sig figs. And we can actually shorthand the word significant and shorthand the word figure to just be sig fig. S-I-G, F-I-G. Makes things a little bit more cohesive. Saying the words significant figure often in quick succession is kind of a mouthful sometimes. So we swap out the words sig fig, making it a little bit easier. Okay, so 3 sig figs present here, right? And again, all based on the fact that there was a decimal point present, so we apply the PL side of the PLAR rule to get us the present left. So we start counting from the very first left number here. That's a non-zero number. 2, 1, 2 is 1, 2, 3, significant figures. Okay, again, we're going to do plenty more examples of this stuff in class, so don't fret if you don't quite get it now. Flip ahead a couple pages, guys, until you see this slide here talking about rounding. This is going to be very, very, very brief review, making sure we're all very much up to snuff on what rounding is, right? So when it comes to rounding, guys, if the number to the right of the place you are rounding up to is either a 0, 1, 2, 3, or 4, you don't round, right? You essentially, they call it rounding down. Whereas if that digit to the right of the number and place you're trying to round is either a 5, 6, 7, 8, or 9, you are going to round that actual number up, right? So we're going to apply that rule going forward. So let's take a look here. Okay, what is a decimal point to, right? Recognizing that we've got a very similar looking number here. Just added on a couple of extra digits here. Initially, this number here was a 230, right? But now we've got this decimal point here. But again, the decimal point adds into the fact that we've now got decimal places to deal with here. Well, what is a decimal place? It's basically any set of numbers that come after the decimal point, right? Anything to the right of this decimal point right here, guys, is considered a decimal place. And I'm sure that is very much, core knowledge for you guys, and is a lot more review than you probably need. But I'm just, kind of fleshing this stuff out just in case there's some things we forgot, especially over the summer, okay? Now, to add into some of our very basic review, and there's a reason why we're reviewing how to round, it's because we're going to need to know how to do this stuff in conjunction with our significant figure rules, right? So although this rounding stuff might seem like a piece of cake for you guys, which is good, make sure it's actually, absolutely down pat when we go to actually look at this through the lens of significant figures, probably next class, okay? So our goal here, guys, is to round to 2 decimal places, right? So you look at both of these numbers here, 32.121 and 34.576. Both of these guys need to be rounded to the 2 decimal place, okay? Looking at both of these, there are a total of 3 decimal places, right? Look at the third decimal place first. If that third decimal place is a 0, 1, 2, 3, or 4, we have to round down that second decimal place. So in this particular example here, because we had a 2 present here, which we wanted to get rid of this 1 by rounding it. This 1 is obviously in that realm of being a 1, 2, 3, or 4. So it's actually not going to round our 2. Our 2 is going to just stay as it is, right? So 32.121, rounding this to the second place, is going to make sure that it stays at 1, 2, 1, okay? Next up here, if the third decimal place in this case is either a 5, 6, 7, 8, or 9, you're going to round up that place, right? So in this case here, guys, we want to keep this 7 here, right? That is our seconds place, and we're going to use the 6 to try and round it, right? 6 is well within that range of being either a 5, 6, 7, 8, or 9, so therefore we are actually going to round up the 7. The 7 is going to become an 8, so our new number is 34.58. 34.58. Okay, and again, I'm sure that is very much review for you and probably rolling your eyes at me right now. But that's okay. Hold on to that. Make sure you're very, very solid with rounding stuff because, again, we're going to need to reapply it through a different lens next class, okay? That is the end of the video, guys. So thank you very much for watching, and I will see you in class.